going to do now, we're going to see what happens if I decided that I want to implement the basically this stack using my linked list data structure. So as you can know, as you remember, linked list are nodes, and nodes are basically, I'm trying to show you how the node's going to be look like. So the nodes are basically, just each node knows who is next. So it's kind of like a chain of nodes, and we have the very first node is going to be our first, or our first indexes or first reference is going to keep that reference of the very first node, and the last is going to keep track of the last node. So again, I have to now decide which methods I'm going to pick to implement, or the behavior of this linked list be the behavior of the stack. Like, first in going to be first, last out, and last out is going to be first in. So leaf or philo data structure. So if I pick the same thing, add last and remove last, like what we did in the array list, that would exactly act as a stack for us as well. But the problem is removing last is going to take this order of n in the singular linked lists that we implemented. So that's not a very good option. But if I change that, right, basically if I look at this, if I pick that add last and remove last, that means I basically think as my last as the top of this stack. But if I change that, so I kind of change my view, and I feel like, okay, you know what, I'm gonna look at the first as the top of my stack, and that way then I can pick add first and remove first, which both of them are order of 1, to implement my stack. So basically when I add elements into this stack, add them to the beginning and the basically of the stack, which is it's always going to whoever is added last when you add first into this, or whoever you added, the last element you pushed, the first is always going to point to that, and it's kind of changing the address to that one, right? So when I added, for example, if I call, like again what we did in the example, if I push A, first and last both going to do to point to that, and that's going to be also on the top of our stack. Then I call add first and I push B this time, then B is going to be on the top of my stack, and so first is pointing to B, which is kind of like my top of the stack, and then A or last is pointing to A. And then when I pushed C into the stack, then first is going to point to C, and last is still going to point to A, right? So A was the very first element I added to the list, and C was the very last one. So first, or the top now, is pointing to that last element, which was C. So it's when I start removing, if I call remove first, that is going to remove the basically very last element, and that's C. So push A and then push B and then push C. So I'm going to demonstrate that. So when I added B, then first is pointing to B, and then when I added C, I'm trying to add C now, then first is pointing to C. So the top or the last, the top or the first are going to be the elements that we recently pushed into the stack. And so now finally I push C into the stack, and so C is going to be on the top of my stack. And so this push method is implemented by adding first. So calling the add first method of linked list. So I kind of make them orange colors, so you can see that it's going to give me order of 1 complexity. And then when we're trying to remove, or basically we're trying to implement the pop method, we also have to call the remove rest method of our linked list. And so that will going to, or that basically going to remove C from the top of our stack. So this implementation also is a very good implementation, right? So push is implemented using the add first, and that's order 1, and pop implement using remove first, and that's also order 1. And if we're trying to get access to the pick method, we just need to, that also going to give us order 1, because the pick is always going to be what the word first is pointing to it, which we do have that as well, and that is also going to give us an order of 1. Search, no matter what, is always going to be order of n anyway. So that way, so that's kind of basically showing you, tell us that was a good implementation. But if I pick the add last and remove last of the linked list to implement the push and pop method, then the remove is going to take us order of n. So in comparison, we definitely want to use the add first and remove first to have a better performance and better complexity if we want to implement the stack using the linked list. So let's write down all of the things we just learned. So adding first and removing first are going to be our push and pop method. They're both giving us order of 1 complexity. Pick is going to be really fast because it's always going to pick the one that is in, or it's basically index first is pointing to it. So that's going to be really fast as well. Search is always going to be order of n no matter what. So those are going to be our implementation for the linked list. So let's make this table for our reference. So yes, pick is going to be, order 1 for sure. As I said, I guess I said it 1, but by mistake I wrote it n, and that's because pick is always going to pick the one that is on the first. The first index is pointing to it basically, and search is always order of n. Perfect. So now we have our tables and we're ready to go to our code and implement the same thing. So the only question that you might ask is that why, it doesn't matter, like my array list or my linked list, we can implement this type, using any of them. And does it matter really? Do we have to pick one of them? Or which one is better? So we're going to implement both of these, right? So we implement the stack and queue both with array list and linked list that we implemented previously. And then we also talk about the benefits of, or basically disadvantages and advantages of both of them. So, what is it? Like array list is better to implement the stack, or linked list is better. Like just comparing the, complexity of them, it's not telling us which one is better, right? So it's really hard to tell. They're exactly giving us similar complexity as far as push, pop, pick, and search methods. So let's go back to our code now and see. First, let's start implementing them, and then we're going to later discuss this more. So as you remember, this is our code for. You're gonna also submit your queue and your stack. My queue, MyStack as well, like what we did with my array list and my linked list. So here we're also going to implement a new class, a new Java class. I'm going to call it MyStack. Actually, I'm going to call it specific MyStack of array list. So make it clear that we're going to use my array list in the background of this stack. So for sure, a private variable that we want in our stack is a type, a top variable. It's an integer type, so acting as a size really. And then in the background, we're going to use my array list to store the data of this stack. So I call it MyStack, and it's going to be really the type of an array list. So as you can see, it's private. So whoever using our stack doesn't really know and doesn't really need to know what kind of data structure we use. So this MyStack of array list class, or this the way that we're implementing this stack is basically we're using what we call composition relationship. And this stack is a wrapper class that's going to, wrapping around my array list class. So this is going to give us the benefit of having access to all the elements, all the methods that we already implemented inside the array list. So we do have that advantages, but then we can also make that access to this my array list limit by MyStack. So MyStack is not going to have access to all the elements and all of the methods of my array list, because we wanted it to act as a LIFO data structure, right? So stack is a LIFO, last in first out type of data structure. So we don't want it to have access to all of the my array list methods. We want to be very specific, and we wanted, no matter what, we wanted it to behave as FIFO. So the methods that we're going to implement for it, like what we saw in the on the slides, we also want to do the same thing. So we're going to have is empty method, but in reality we're not really going to implement these empty methods, because since the stack is using the array list in the background, and we already have empty method implemented in the array list, I'm just going to forward this call. So our client creating a stack and called an is empty method. In the background, our stack is going to create an array list and is going to forward the call of is empty to the array list as well. So everything is going to be handled. It's kind of like MyStack is an interface, really. It's not doing anything. It's just delegate the job to the array list to do the job. But it's also handling the jobs in a very limited way, that it knows exactly which methods has needs to jobs. So as you can see, for example, in the case of push, right? So push knows that we need to have an element. Again, we're just using the strings again, but we're going to change all of them to generic types. So it's going to push a string, but then it's going to call the add last method, as we discussed in our Excel sheet of the array list. We're also maintaining the top just to make sure we have the value of the top. So we're just calling the get size method every time we're adding or removing something from this stack. I want to know what is in the top of the stack, so I call the peak method, and the peak method is going to call the array list get element at the top of the stack. So since we already have the top variable maintained, so we can use top -1. We could also technically use MyStack that gets size -1 as well. That would be also another alternative to implement this method. Another method that definitely we want is going to be our pop method. So I make all of them making void. So pick has to be a string because it needs to tell us what is the element on the top. So pop method is going to call the remove last method of our array list, and also I'm just maintaining the value of the top by getting a size. We know for sure that the my array list, we already tested it, and we know that our my array list maintaining a size, the value of the size is correct, is always going to be updated when we're adding or removing elements. So pop and push also going to maintain the top. We can also implement the search method, and our search method also is not really doing anything in the stack. It's just going to forward the call, delegate the job to a method inside the array list that it knows better how to do it, how to handle it. So it's going to call the search method of the my array list. So that's it. There you go. We didn't really do anything, right? So as you can see, we didn't do any implementation. We just like whatever method we had, we just forwarded it to a correct method in the array list. And that's why, again, as I said, these types of classes, they're using composition. We have an array list data as a data field, and they're not really doing anything. They're just delegate their job. We can also have our print method because we want to test. So even for print method, we didn't have to do any implementation. My array list already has the print method implemented. So here again, I have to just delegate the job. So forward the job and call the print method of a array list. Now let's test our class MyStack of array list and make sure that it's actually working. And as I mentioned, this is a composition relation that we have here between the MyStack of array list and the myArrayList class. So then in order to test this, I'm just going to create in the client or in our list test class, we're going to have a variable of type MyStack of array list. And then we're going to start testing it. So basically, as you can see, this is a composition relationship, and we're not really doing any task here. So this is a very important. We also kind of had similar situation in our tic-tac-toe game we did in the class, right? So the wrapper class that we implemented inside the tic-tac-toe, not really implementing anything as far as like the actual tic-tac-toe game. It would just forward it. So this is our test. So we're just checking, you know, that at the beginning the stack is empty, and then we start pushing ABC, and then we just want to see who is on the top of the stack, or we also search for B. So it's telling me B is in the index of 1, which is correct because we technically have to have C in the last, B in the middle, and A in the index 0. And then we pick is going to be C, correct, and then we start popping. So as we pop, we expect the very first pop is going to be C, and then B, and then A. So it's working fine. And since also we used an array list of capacity 4, you can see as we start removing elements, you know, the capacity is not divided by 2 as well. So now we'll notice that you know, we can easily implement this new data structure using array list. Now let's do the same thing and implement this stack using a linked list. So I'm going to call this MyStack of linked list. And we're going to basically do what we did already. So it's going to be very similar to the stack of array lists. I can even just copy paste everything from here. The only thing I have to do is changing the variables of my array list to my linked list. So here anything goes to array list, I'm going to change that to my linked list. So again, here we also did use the composition relation. The only thing is now we have to forward the methods to correct method that we have in my linked list. So for example, in the linked list, we don't have get elements. We haven't implemented that. So we have to go ahead and implement that method, or basically we can change that to get first, right? Because it's really like based on what we implemented or what we decided to implement, we need to call add first and remove first for push and pop. And we know that the pick is always going to point to the same place that the first pointing to it. So if I can get hold of the first reference, then I can find that string. So it's better to implement a method get first inside my linked list. So we're going to do that. So let me change the remove first in the pop. And then also our search method has an arrow. So let's look at it, see why our search method in linked list is different. Because I guess the search method is a Boolean type here, I believe. Yes. So we'll just have to go ahead and change that. That's not the big deal. But you also have to add the method that is telling us who is in the top of our stack, or who is first pointing to it. So I can change or create this method here. Yes, so search is pointing to, it's a Boolean type. So I just have to go ahead and change that a little bit. And also we need a method to tell us that who is on the top of the stack. So for that, I need a method called get first. So get first actually going to return the particular node, which is the first pointing to it, and it's going to return the element that we stored into that. So you can also have the get last element just to be safe and for be consistent. So this is going to return first dot element. And this is going to return the last dot. Perfect. So we have our code ready. So we're going to change those two here. So we know for sure we have to get the first. And here we know that our search is going to be returning Boolean. So we can later on create a list interface as well for ourselves. So all of our methods going to be look like the same as each other, so we have be more consistent. So like for example, all of our search method be Boolean, or all of our search method be returning an integer type, so that way we are going to be more consistent. Okay, perfect. Now we have to test this. We're going to do exactly the same thing as we did actually not even going to change thing that much here. We're just on a new variable and then comment the old variable. And technique, I mean, as you can see, I don't even have to change anything, just running it, and perfect. So working the way we wanted it. So B is in this list, and then we remove first C is gonna be removed, then B and A, but when we added the element A, we added A, B, C, so it's gonna be in there. So another question is, well, we know that we implemented with array list, and we know we implemented with linked list. We just did the comparison between all of them, and we didn't really we can really select any of those two. And is there any benefits of using linked list or array list? And the answer back to the same thing we talk about the application of the array list and application of the linked list. And now we have to see what is our application of our stack. Usually when we use a stack, the main application of the stack we all know is call a stack, right? So when you're calling main method and main method calling other methods, those methods are all going to go to the stack, and we call it call a stack on top of each other. So we did it in the recursions, right? So when the method call itself, it's keep going on the top of the stack, and then the last one, the stopping point, basically when it's finished, then it keep coming out of the stack one by one. So that's one of the very important applications of the stack. So the stack has a lot of applications, and so as you can see, most of the time we have to add a lot of elements into the stack and remove them from the stack. And so we don't really know how many of them. So if you really think about those types of application of the stack, for example, the one that we just explained in the call stack for the recursions, we may not, it may not be beneficial for us to use array list because of the fact that, the resize method is going to add a lot of overhead, and we don't really know how many elements we're going to add. So we keep adding and removing, and that's going to be very expensive as far as resizing for array lists. But if you're trying to add and remove in the linked list, that's not going to be very expensive, right? So it's always going to be order of one. So that is going to be more, and we don't have this overhead of resizing, stuff like that. So I guess it's kind of like, makes sense that we only use a linked list in order to implement the stack, not the array list. So that doesn't really make sense to use it unless the stack, the application of our stack, when we want to use our stack, when we think about why and how we're going to use this stack. If you notice that we don't really have too much adding and removing, which is kind of weird. Why then you want to use a stack? But again, you have to think about the application of it. But most of the time you see that it's going to be implemented, it's better to be implemented using the linked list. So next